Hi, I'm Rich Blumseth with Echelon Corporation. Today I'll demonstrate Echelon's new IZot platform and how you can use this platform to create highly reliable communities of devices for the industrial Internet of Things. I'll demonstrate Echelon's two new products, which are the IZot Device Stack and IZot Server Stack. With the IZot Device Stack, you can create devices that discover each other and form communities of devices that share data within the community. With the IZot Server Stack, you can create a device that acts as a server for the community, collecting all the data from all the devices and making that data available to web pages and other applications. Both stacks are available as free software downloads that include C, C++, and Python source code that you can port to a variety of platforms. Today, I'll show the stacks running on the popular Raspberry Pi platform. The Raspberry Pi is a great platform for the IZot stacks because it is a complete but compact platform that runs Linux and costs $35. The IZot stacks do not require the Raspberry Pi, but it is a great way for you to get started to prototype your next great invention for the industrial Internet of Things. So now we'll move to the IZot lab and actually look at the IZot stacks in action. In this lab, we've set up a panel that has a number of devices running the IZot stacks. This panel demonstrates a typical network for the industrial Internet of Things. Some of these devices are sensors, like our environment sensor and our touch keypad. Other devices are actuators, like our LED controllers. And all of these are running the IZot device stack. And here we have an IZot server running the IZot server stack. We'll start with the IZot environment sensor. The environment sensor senses temperature, humidity, light level, and occupancy of an area. To create the environment sensor, we designed the hardware as an I/O board for the Raspberry Pi, using sensor modules from Adafruit. We used a DHT22 temperature and humidity sensor, a light level sensor based on a TSL2561 light level sensor, and a passive infrared sensor module. We include schematics with the IZot device stack for all the I/O boards that I'll describe today. For example, here's the schematic for the environment sensor. To test our design, we first created a breadboard that connected a Pi to a breadboard containing the sensor modules I just described. This was a hand-wired prototype to just verify that the design is correct. Once we verified the design, we created a few more prototypes based on 10th-inch center prototyping boards. This allows us to have a nice compact version of our environment sensor that we use for testing. To develop the software for the environment sensor, we used the Python package included with the IZot device stack, and we also used PyCharm, which is an integrated development environment for Python. You can use the Python environment of your choice, but here we'll be demonstrating with PyCharm. So here we're looking at the source code for the environment sensor within PyCharm, and this is the code part of the code that implements the sensor. Here you can see the code for the occupancy input, which is what responds to a physical change in occupancy, reads the data from the sensor, and writes it to the network. So as you can see, writing a value to the network is as easy as writing a single line of code that takes a piece of data from some physical sensor and reports it to other devices in the community. To run the environment sensor, I'm going to use the SSH console built into PyCharm. With the SSH console, you can see here at the bottom of the screen, I'm looking at a console for the Linux that's running within the Raspberry Pi for my environment sensor. I'm going to enter a command to actually start the sensor application. So the sensor application here is just called keypad 2. So I just say start it up, and that actually will start running the application on the device. You can see the application starting and initializing, telling me the state of the application, and this actually gets our sensor running and on the network. After I loaded the environment sensor, I went ahead and loaded the rest of the devices. So my network is now up and running. So I'm going to go to the keypad now and show how I can control the network from here. I can push the on button on the keypad and all the lights come on. But now I also want to be able to change scenes from the keypad. So let's say I push the TV scene. I like lots of color when I watch TV. Here's the TV scene. Or let's say I want to watch a movie. I like different colors when I watch movies. So that's how I can control the network from here. So now we're going to look at one of the web pages included with the IZot server stack. Here we see the dashboard page, which is dynamically built as devices are discovered. Here we see power, we see the values from the environment sensor, we see the state of the light. I can change the light here. Or we can go to the second tab, which is the color picker. From the color picker, I can click on a color and all the lights will go to that color. Now these pages are customized for this particular demonstration. We also have two pages that are tailored for developers. So developers have the device browser that lists all the devices that exist within the server. I can look at a device and see all of its attributes, and I can change its attributes. And the final page is a test page. This is what developers can use to learn the REST API. So from the test page, I can enter a REST API command into the page, click request, and get the response from the server. You have now seen the power of the IZot platform. Get started today by downloading our free software from our website and see what kind of cool devices you can develop for the industrial Internet of Things.